All right, now in this problem, we've got a triangle, and they give us the three coordinates of the vertices, and so it's a good idea, I think, to sketch it. You can use a grid or not use a grid, but I would suggest that sometimes it's kind of easier to visualize what's going on. So if I do a quick sketch, and again, it's not like I'm going to solve it by sketching, but it's going to give me an idea of the ballpark I'm in and whether I'm on the right track or not. Helps me visualize it. Anyway, when I get my triangle, it kind of looks like this. And what they're telling me is that there's this point P. And point P is the foot of a perpendicular line that goes from B to AC. So the foot is the part where the right angle is. So if I visualize a line that goes from point B to AC, but at AC it creates a right angle, it's going to look something like this. And again, I don't have a protractor, so I'm not measuring. That may not be accurate, but the P is going to be somewhere up there and around that area. And I do know it creates a 90-degree angle. So now I'm looking for this point P. And I kind of figure out my plan. My plan is to find the slope of AC, because I got 2 points, and then find the equation of AC, and then find the slope of BP because they're perpendicular, and then find the equation of BP. And once I find the equation of BP, I know AC and BP, and so then I can find out where they intersect by solving them simultaneously. And then I've got to use the distance formula to figure out 6 and 7. All right, so using the plan, I want you to go ahead and try to do parts A, B, C, and D, and then start back up again when you're ready, and then we'll compare. Okay, so to find the slope of AC, I'm using the slope formula, y2 minus y1 over x2 minus x1. And I find out that the slope is going to be 1/3. And so I make sure I label all my information that I found in a problem like this. And then if I want to find the line AC, I'm going to plug in the slope and one of the points. In this case, I guess I'll use 8, 8. It doesn't matter which point I use. And when I do that, I'm going to find out that the y-intercept is going to be 16/3. So when I put that y-intercept together with the slope, I've got an equation of the line, y equals 1/3 x plus 16/3. And again, I'm going to put that up there with my other information. And now I'm going to take a look at part A. Part A is finding the equation of line BP. Well, see, now I know the slope of BP. That's got to be perpendicular to AC, so I know it's a -3. And I only have the point B, that's 3, -7. So when I put that into the equation and find the y-intercept, I find it's 2. So now I know the equation of BP, y equals -3x plus 2. And then when I go to look at B, I want to find the intersection of AC and BP. Well, all I'm going to do is solve these two lines I've found simultaneously. So if I make 1/3 x plus 16/3 equal to -3x plus 2, well, I'm going to multiply both sides by 3 to get rid of these fractions of 1/3 and 16/3. And then all I got to do is get x by itself. And when I do, I find out that x is equal to -1. When I substitute -1 back into the original equation, I find out that y is going to be 5. So now I know that point P is actually -1,5. Obviously my picture was off, but it's not terribly out of the ballpark. And see, now when I go to C, I'm going to go find the lengths. I've got the 2 points. All I do is use distance formula. And so when I do the same thing for BP, I find that length using the distance formula, because again, I got all the points. And then when I'm trying to find D, I find the area of a triangle, which is 1/2 base times height. In this case, the base is AC, and the height is going to be the perpendicular line from the base, so that's going to be BP, which I've already figured out both of those. And so when I put them together, I find out that the area of that triangle is going to be 100 square units. Okay, thanks for watching. Hope that helped.